Today we'll learn how to find angles inside a triangle using the trigonometric ratios for sine, cosine and tangent. So again, we have a bit of a recap on our trig ratios, so sine theta, cos theta and tan theta, or maybe they're better known to you using your SOHCAHTOA memories, a memory trick. Alright, so for both of these two examples I'm going to go through, it's important that we start off using our SOHCAHTOA again. So in our first triangle, so we want to find the measure of the angle marked theta in both of these. So I want to know what the value of theta is in a question like this. Very first thing we want to do, we need to label our triangle. So opposite over here, and this side is next to it, so it means it's adjacent. So we go through all of these options. I don't have opposite and hypotenuse, I don't have adjacent and hypotenuse, I have opposite and adjacent, so I know I'm using tan here. So I have tan theta is equal to my opposite, which was 4 over 7. Now in order to find theta, I need to do the inverse of tan. Alright, so that is the thing that looks like a tan -1. That is the inverse of tan. Now to do that, on your calculator, you'll need to press shift. So that's the big yellow button on the left, and then you would press your regular tan button. Okay, that would give you tan inverse, or tan to the -1. Okay, so how do I actually do this, or what is the algebra? Well, I had my first step, tan theta is equal to 4 on 7, so that means theta is equal to tan inverse of 4 on 7. So I want you to have a go at putting that in your calculator and make sure you get the same number as I get. So that's going to give me tan inverse of 4 on 7, and that is equal to 29.74 degrees. Okay, now let's have a look at a second example. So theta is here, that means this here is going to be my adjacent, and I have the angle on the opposite side, and that is my hypotenuse. So if I look through, do I have sine? I don't have my opposite and hypotenuse, so it's not sine. My next one, cosine, adjacent and hypotenuse. Well, I have my adjacent and hypotenuse, so it's going to be cosine. So let's write that down. We have cos theta is equal to my adjacent, so that is 2.67, all over my hypotenuse, which is 5.92. So then my theta is just going to be equal to cos inverse of the 2.67 all over 5.92. Right, and just because they're ugly decimal numbers doesn't mean that this won't work. So theta will be equal to, so I do shift cos, and that should bring up the cos -1 on your calculator, and then you'd put in 2.67 divided by my 5.92, and that ends up giving me that theta is equal to 63.19 degrees. So what that means is I know that this theta, or that angle in there, is actually 63.19 degrees. So now, hopefully you're able to calculate lengths on any sides using SOHCAHTOA, but you're also able to calculate angles if you're given two sides.